Hello, I'm Eric Snodgrass, and thank you for watching this weekly ag weather forecast for Ag Carolina Farm Credit and Ag South Farm Credit. Now, in this particular video, we've got a lot we're going to try to unpack here. I'm going to spend some time just talking about recent precipitation patterns, and then I'm going to tell you why we've been in this particular kind of phase of the atmospheric flow. I'm going to ask some big questions right in through these tabs in through here as to where we think this is going to go into summer. So that's going to be an important part for you to watch. I'll then come back to the near term, give us a forecast over the next couple of weeks. We'll then look once more at the new long-range data from the European weeklies, getting us out to mid-July, and I'll finish it up with an international update. So that's my plan for today. I've left you on the U.S. Drought Monitor, which was just updated yesterday, and we look at this every Friday because we're trying to assess what the longer-term drought stresses look like across North America, specifically here in the U.S. And in the lower 48, we're currently at about 12% of the land area in D1 to D4 drought. And technically for the southeast, except for Florida, we are drought free. We just have a couple of areas of abnormally dry conditions, as you can see showing up there in that light yellow. Now, I'm going to make a case out of this as to what you can't see on the map in Mexico in just a few moments. But what I want you to notice is that in terms of drought area for the entirety of the U.S., the last time we were this low was back here in 2020. So spring of 2020 was the last time we saw that small amount of drought. And if you want to focus in just on the southeast, this is what your drought time series looks like going back to the year 2000. So again, it's area of the southeast covered in some form of drought, which is color-coded here. And we have questions, right? What drove these large drought episodes back in the early 2000s, or the 2006, 2007 into 2008? What about 11 into 12, or here in 16? We have questions as to whether or not we build into that. And I've made a case for you, right? It's going to have to be some sort of large southeast ridging. And big picture is right now, before I even get into the details, no model's predicting it at this point. But we have to know that it's always a liability in our forecast. So what are the models predicting? Well, if you look back from April into May and now into early June, so much of what they're about to show us is going to reflect where we have been. And if you just take a look at these statistics, which are precipitation ranks by climate district, it's pretty clear that there's a corridor in through here that's been exceptionally wet. So I'm saying that the predictions I'm about to share with you, all of those models were initialized with very, very wet conditions in this area. Now, as I look at it, you can see how dry it's been in parts of Florida versus how wet it's been in eastern Texas. We can take note of how wet it's been across the southern tier of Georgia, but there has been, if you look over the last 2 months, there is a drier area in parts of North Carolina that can't be ignored. Now, yes, lately it's been better in that area for precipitation, and this is why we don't have drought here. But just in the month of May alone through early June, near record wet, and actually record wet down here, record wet at places in the Mid-South, very, very wet in this part of the Corn Belt. And these things are going to influence where this longer-term precipitation pattern is going to go, because back at the beginning of all of this, back at the beginning of April, much of the Ohio Valley, the Mississippi Valley, the Missouri Valley was very dry. We were looking at decent soil moisture up until April. And then we've had a couple of pockets that have gone over drier. This is the newest soil moisture map as of June 7th. This is root zone soil moisture. But again, what I want to stress is with what I'm about to share with you, every long-range model was just initialized with wet conditions, very wet conditions in this area. Just stuff that away in the back of your head for a few moments. Now, if we look at just the last 7 days, we had some absolutely torrential rains coming through parts of Ag South and Ag Carolina's territory here, some places picking up several inches in a short amount of time. But if you look back farther to your west, 7 days, repeated storms rolling through parts of the South, big storms that have rolled through parts of the Midwest. I mean, we've been extremely stormy this spring. We're going to talk about why that's been the case to give us what's already been well over 1,100 tornadoes reported so far this year. We're at about 165% of average on wind reports and 110% of average on hail. And speaking of hail, I don't know if you saw this, but I'm going to take you to Texas really quickly because you just got to see this. Back on June the 2nd, a storm that blew up here in the Panhandle near a town called Silverton, not only produced twin tornadoes here, but also produced some absolutely monstrous hail. And I want to thank Val Castor for giving this to the National Weather Service so I can actually show it as well. He's given us permission here. So on this .gov site, you can now see that might be the new state record holder for hail. Now, I know that's outside of your territory. I just need you to see this, okay? It was an absolutely huge storm system. So where did we get over the last 24 hours? Well, we watched the system finally exit the coast. It's offshore now, but it did locally drop some very heavy rain in Virginia, North Carolina, and also getting back into parts of Alabama, but mainly Georgia, getting into southern Mississippi, all the way down to New Orleans. But this low that's curling up here over the Great Lakes is a part of a bigger pattern shift that happened this week, including the opening of a large ridge into the west. Now, that ridge that's delivering all of this heat into the west can't stick around for long. It's breaking down, and we need to see what the implications of that are going to be in the longer term. So here we go. This is the long-range stuff I want to talk to you about. Now let's just sit and marinate in this map for a second, because what it shows you is the dominant factors in May. And our question is, did the factors that controlled May control June and July, and maybe even later into August? Because what it's been dominated by are these ridges, one sitting here and another sitting there. And to the north of it, the jet stream is screamed around the base of a trough in the Bering Sea, rolled over the top of this ridge, and just raced toward the south and curled around a low that is set right here, that one, in kind of the central part of North America. While this has been going on, there's been other factors, like ridging that's happened from Mexico over to the Caribbean, getting Florida. The Bermuda High, which normally sits here, is not there. It's split. There's a piece that's way up in parts of like the Canadian archipelago and the Hudson Bay. Another piece that extends all the way into like almost Scandinavia. See it here? Just kind of flip over on this side of the map. That's driven flow around that ridge into Ukraine and the Russian grain belts out of the northwest before it curled out around this trough. And that's the drier side of a trough, which is why we've seen such extensive drought developing in Russia's western grain belt and parts of Ukraine. I want to know, what do these pieces look like going forward? Because they've driven some pretty wild precipitation extremes, which you've already seen for the United States. But let's talk about Mexico, because the drought that's in Mexico right now is showing up as one to be considered historic. There's been wildfires down here in parts of southern Mexico for the last 2 months, all spring long. And if you just take Mexico on the whole, it's the driest it's been in the last 80 years. And we have questions as to how this drought influences the pattern along the southern tier of the United States going forward, and what it might mean even later for influencing the hurricane season. So all of that's ahead of us. We've now seen where May is, and we got to start to talk about what this could mean going forward. And here's the first thing. The MJO has lived here. That's where our best rising motion has been, right in this area. And as a result, kind of a complement to it, half a world away, we've had a lot of sinking motion in Central America and Mexico. These two things are changing right now. That's one thing that's changing. And this is a lid coming off of the atmosphere here, meaning that we have got to start to prepare, all in this area, for some tropical moisture to start to surge north. Am I talking about a hurricane? Not yet. I don't have evidence of that yet. But moisture is going to start coming into this area. And at the same time that that's beginning to shift, we have to ask what's going on in the North Pacific. So I want to show you something we've looked at in the past. It's called the PDO, Pacific Decadal Oscillation. And when I say decadal, let's just zoom in here, since 2013 and look at it. What we typically find is that it goes for about 5 years in a positive phase and then about 5 years in a negative phase. What's interesting about this recent kind of PDO signal is right here in May. Because in May of 2024, I had been anticipating that this was going to start to make the turn. And instead, May of 2024 dropped the bottom out of the PDO. And we need to understand what that means and what are the implications of that. So let me show you. In May, going back to 1940, if the PDO is negative, we tended to have ridges, one here and one there. Now, I just showed you that that's typically the case. There tends to be a trough to the north of it. This year it's a little bit farther to the west, but a trough to the north. Look at this, a ridge in Mexico that sometimes expands into the eastern United States. No Bermuda High. It tends to split part here and part there. Now, how close were we to this year? Well, the Mexican ridge was down here, and the loss of the Bermuda High sent pieces much farther to the north. And again, this trough this year is over there. So it's not fully a PDO-only signal. What I'm trying to say here is that the PDO, though, owns the lion's share of where we've been in May, and we want to know if it's going to own the lion's share of June and July and August. I'd say it's about 70% of the pattern. What's contributing the other 30%? Well, we need to get to that in a few moments. But to understand that PDO, what we're going to watch is these ocean temperatures. Because historically, when the PDO is negative, We are very warm here with cooler water lining North America. We tend to have a broad La Nina signal. We don't have that this year. We tend to be cool across the Atlantic. We don't have that either. That's why it's not fully in control of this pattern. But if we just say, well, what does a negative PDO mean for air temperature going into summer? It does not translate into major heat risk for the southeast. You say, why? Because normally it places a large ridge of high pressure over Texas, maybe New Mexico, maybe getting into Oklahoma, Kansas. And if it's there, it's not here. You see, what would dominate us is if the Bermuda high regained strength and then flexed to the west and hit us. But that doesn't typically happen when the PDO is negative like it currently is. So we tend to not see significant heat stress in summer. Now that does not mean, listen to me carefully, that does not mean because of this one thing we won't get hot this summer. We will get hot. I'm talking about the significant sustained heat stress scenario is lowered because the PDO is negative. On the precipitation side of it, that's where it also tends to be drier. We tend to not see